Hello friends, in this video I will be talking about linked list from the very basic of what a node is. Then we will go on to solve a few easy level lead code problems, medium level as well as hard level lead code problem as well. So without further ado, let's look what a linked list is. So think of a linked list like a city. What does this city contain? This city contains nodes. Just think of it like people. But this node doesn't know anything. It just know two things. What are those two things? What is the value and who their next neighbor is. These are the only two things that this node knows. I will repeat again, it knows only two things, what is the value and who the next neighbor is. So how does this actually form a data structure, right? Very simple. It looks very simple, but how does it actually form a data structure that is actually widely used in the industry? So if you observe here, this node knows who the next neighbor is, but that neighbor also being a node will also know who the next neighbor is. So this will actually form a chain structure like this, which will actually form a very strong data structure. So here, if you look, these five nodes are forming a data structure where we can store the values just like an array list, but I will also talk about what is why do we actually need linked list when compared to array list. So this will be the structure of a node. It just contains value and it contains who the next neighbor is. These are the only two things that the node will be having, and these will form a very strong structure like this. So why do we actually need a linked list to store the numbers, right? For example, here 58632, we can just store it in an array, right? So why do we even want another data structure when we already have arrays? So let's look here. So we do have a array here, right? Say we want to insert 4 in between. So if you look carefully here, when we insert 4 here, all the positions of the elements next to the element 4 have changed. So we have to change the position of all these elements, and this will involve a larger time complexity, right? Similarly, when you want to delete an element, say you want to delete this particular element too. So if you look here, all the elements on the right side is shifted by one position again. So this is unnecessary calculations, right? So, but in linked list, we have this advantage. So how do we delete an element? So we will just take it out and we will say, hey, Phi, your neighbor is no longer 8, he is 6. So he will just point to this. That's it. 8 goes out and it will be collected by garbage. It is just like that. It's very easy to remove a node. It can be just done with a constant time complexity. Similarly, to add one more node, it is very easy. You will say, hey, your new neighbor will be 4 and no longer 6. You can just add it here. So it's very easy to add and delete nodes or values in a linked list when compared to an array. But this also comes with a trouble. What is the trouble? We cannot directly access the fourth element, right? In an array, you can directly go to the fourth member and you can ask, what is the fourth element here? But if you look here, you have to iterate from the first guy and you have to go to the fourth member. So this is one disadvantage of linked list. So whenever having a problem, you can either decide which data structure to use based on your particular needs. Okay, so these are the advantages and disadvantages. Now I will be discussing about few concepts that is involved with linked list. So what I will be doing here is, instead of dumping all the concepts together at once, what I will be doing is I will be explaining the concepts, then we will be solving problems related to these concepts, at least couple of problems, so that you get a strong hold on that particular concept. For example, iteration. We will talk what iteration is, then we will solve couple of problems so that you get hold on that, then only we will go to the next concept. Okay, so uh, what is iteration? Say for example, you want to print all the elements in this particular array. What do? You iterate over all of them and you just print. But how do you print them in a linked list? So in linked list, we have one more concept that is called the head node. What is the head node? The head node's job is only one thing. It will remember only one thing, that is who is the first member of the city. It will remember nothing else, only the first member of the city. It will always point to the first member of the city. And make sure you doesn't change this head node unnecessarily, because this will manipulate, or you will not remember who the first member is, right? So you will actually lose the data. So never try to manipulate this head node. So how do you iterate over the array? So one thing you can do, you can send this head node, hey, you are at first point. Anyways, the first point knows who the next neighbor is. Go to the second point, go to the third point. But if you look here, we will lose something, that is the head node. So even if you want to come again, you will have no option, right? So it's better to always have the head node pointing to the first node and never try to change this. Okay, so we will have one more guy called as the iterator. So what he will do, he will go to each point and check if there is a node, he will print the value or note down the value. Then since this node also had address to the next node, he will just go here, and what he will ask, he will ask its value, then he will print the value. So 5 and 8 will be printing. Similarly 8, he will come to 6, then he will be coming to 3, he will then be coming to 2, then he will be going here. But since this is null, since there is no one, he will come out of the loop and all the values get printed. So remember this, whenever writing a while loop, especially with a linked list or a node, it is very important that you write the exit condition very carefully, because that is the only point where you will be facing null pointer exception. So let me take you through the code. So here we will declare a list node that is equal to the head, because it will start at the head pointer. Then while this iterator is not equal to null, what we will be doing, we will print the value of the node and he will go to the next node. Itr will be equal to itr dot next. So what I have done here is I have just created 6 nodes and I have attached all the nodes. The first node is pointing to the second to third, third to fourth, and so on. So let's print the values now. See, the values are printed in order. And if you remember the concept, head is still at 5. So it is still pointing at the first node. So even if you want to print values again, you have the data that is pointing to the head node. So you can easily print the values or use it again. So never change the head node. Remember this. So let's go into the next concept. So in this particular problem, we have a problem. In this problem, a number is stored as a linked list. How is it stored? Each node contains the digit of a number and it is stored in the linked list. So what are you given? You are given the head of the node. Okay, so you are given the head of the node. For example, 58632, that is 58,632, is represented a linked list, and each of them contains a single digit representing the digit of this particular number. Okay, so how do you do this? How do you get this value? So again, the same iterator, you will have the iterator initiated. He will go to the first point, but when he goes to the first point, whatever is the answer, he will multiply it by 10 and he will add that particular element. So the answer will be 5 in the first case. So then he will come here. So whatever is the answer, he will multiply it with 10. So 50, then he will also add 8. So 58. So then again he will go to the next number into 10 plus 6, 586. Similarly, he will go to the next number. He will multiply the existing value by 10 and he will add 3, and similarly 2. So whenever the null comes, he will come out of the loop and say, hey, head, I am done. So we will be returning the head value. So let me write the code for this problem. So just one change here. We will have int answer that is initiated equal to 0. So at every step, what do? We just multiply the answer by 10 plus we will just be adding the iterator dot value. So at the end of this, we will just print the answer. So if you look here, we have got the answer, that is 528631. Similarly, we have a problem on LeetCode, a similar problem. So here if you look, instead of decimal number, what they are asking is binary number. So the only change that you have to make is, instead of multiplying with 10, 10 being a decimal number, we will just multiply with 2 because this is binary, and everything else remains the same. Let us submit this. Yeah, it just ran and also beats 100%. So let's get into the next concept. So one important concept, next concept that I will be discussing is, you want to print alternate values. Say in this particular example, you don't want to print every value, you want to print alternate values. So what is one approach that we have? He will go to this point, he will print this, then he will again go here, he says, hey, he will remember, I have already printed, now I don't want to print. That is, we can keep a boolean, then he will again go here, he wants to print, again he comes here, he doesn't want to print, again he comes here, he wants to print. This is one way of doing this, but if you see, he is going to places that is actually not necessary. So what we can actually do is that, instead of sending him to every place, we can send him by skipping 2 places at a time. Since this guy also knows the next guy, we will directly be sending him here, and from here we will just be sending him here. So how do we do this? We do that by checking if the next element is not null. We will just skip this guy one step and we will send to next dot next. So this is what we are doing here. So he will actually go to the next and the next element. He will skip one element and go to the other element. All right, let me write in this problem. So one base condition that you have to write here is, both the iterator is not null and the next value is also not equal to null. So these will be the base conditions that we have, and he will skip one. So we will have to print alternate numbers. So here if you see 5, 8 and 3, the alternate numbers are printed here. So if you look here, observe very carefully, the first guy here in this was just traveling one step at a time, or he was traveling at one speed, he was just traveling one step at a time. But the guy here was traveling 2 steps at a time, that is, he was skipping one step, right? So if you look here, you will find one observation, that since both of them are walking at, the second guy is walking twice the speed of the first guy, when the first guy is at 100th node, where will be the first guy? The first guy will be half of it, the middle of it, that is at the 50th node. So we have a similar problem that we want to solve, that we will be solving using a fast and slow pointer. So we have to find the middle of a linked list. So how do we find it? One option we have is, we will count how many elements are there. First, this guy will go 1, 2, 3, 4, 5, 6. So he comes and says, hey, we have 6 elements. So the middle element is the third element. I will go there and I will find the element. So 1, 2, 3. He will come here and say this is the middle element. Okay, but if you look here, we are unnecessarily performing 6 operations. Then again we are performing 3 more operations. So if it is a very big linked list, we are unnecessarily doing calculations, right? So we will use a concept that what we have learned now, that is fast pointer and slow pointer. What we will do, we will both initiate this fast and slow here. So the fast will move 2 steps at a time and the slow will be moving 1 step at a time. So he will be moving here and this guy will just be here. So what is the middle element? The middle element will be 6 in this particular case. Since there are even number, what we will be asked in the problem, it will be the next number. So how do you find it? If there is a next element, this low guy will go to the next element, or if this particular element is absent, he will stay here only and print the element. Let me show you the problem here in lead code. So how do we solve this? Let me get into the code. So you will declare a first pointer that is equal to head, and you will also declare a slow pointer again that will be equal to head. So what is the next condition? This is very important. While fast dot next not equal to null, the next element is not equal to null, and fast dot next not equal to null. So what do we do in that case? If it is not equal to, fast will be equal to slow will just move half the speed, that is slow dot next. So whenever we are at the end, so if you look here carefully, whenever we are at the end, that is if fast dot next not equal to null, we will just print the next value, that is slow dot next dot value. Else what will be the middle element? It will just be the slow dot value. Let's just test it out. So we have 6 elements here. So let me run this. So the answer is 6, that is the 4th element. Let's remove the connection to the last element so that there will only be 5 elements. So we should actually be getting 8 in this. So that is the middle element, and this is how you find the middle element. So the same problem I have solved here. So we have initiated the fast and the slow pointers, and let me just run this. And also submit this. Yes. So these are two very important concepts when it comes to iteration. That is, one is normal iteration and fast and slow pointers. This concept can be used in many other problems that I will be discussing in the future, like cycle and how do you find the starting point of a cycle and everything. We will discuss that further. But without further ado, let's get into the next problem solution or the next concept. What is the next concept that we will be discussing? The next concept that we'll be discussing is how do you delete a node? So you can delete the node in 2 ways. I will be discussing both of them, and you can choose which one you prefer based on your choice. Okay, the first thing is we will have 2 guys. One is the previous guy and one is the forward guy. Both of them will actually walk at the same speed, but one guy will be one neighbor forward than the next guy. So if this guy is here, he will be here, he will be initiated to null, he is at head. So when in the next iteration, this guy will come here, this guy will go to the next step. So similarly, this guy will come here in the next iteration, and he will go to the next iteration. Okay, so say we want to delete an element whose value is 3. So how do we do that? So in the next iteration, he will come here, and this guy will go here, and this guy will say, hey, I have found the value, that is 3. So what do? We say the previous guy to remove the next node, and we say previous dot next is just equal to previous dot next dot next. So we'll just be removing the connection, and we will be attaching these 2 nodes together, and this node will be removed, and the remaining elements, that is 5, 8, 6, 2, 1, will form the new linked list. Okay, so this is one way of removing a particular node. Let's say, what if we want to remove the head node itself, right? Say when this guy was here and this guy was here, the previous node is equal to null, and you have found the value to be 5. Say you want to delete 5, you have found the value. So what do? You will check the previous guy, he is null. So if he is null, this is a special case where you want to change the head pointing to the next index, that is head dot next. So this is how you delete an element. So let me write the code for this and show you. Say we want to delete this particular element 6. Okay, so we will have again 2 pointers. Which will be pointing to head, and the list node, previous node will be pointing to null. So while the iterator is not equal to null, what will happen when he is not equal to null? If iterator dot value equals 6, what we will do? We will check a condition. If previous is equal to null, what we will do? We will change the head node pointer. Head is equal to head dot next, and we will just break and go out of the array. I mean the while loop. So if it is not equal to null, what do we do? Previous dot next is equal to previous dot next dot next. This is when you find the element. This is what will happen. And what do? We will just break out of the loop. So if you have not found the value, it will be simple. Previous will become the current iterator, and itr will just be iterator. So after all this, let us just print all the elements. So let's again initiate it to head, and let's see. Yes, so 6 is deleted here, so the remaining value 528631 52831 is present. Say we want to remove the first node itself, that is 5 itself. Let's see what happens. So 5 is removed, that is the head value because of this special condition. So guys, this is how you remove a node from at any given point or from the head also. Okay, so next we'll be getting into one of the LeetCode medium level problems where you have to delete the middle element of a linked list. So here what we will be doing is same. We discussed how to find the middle node, that is we will use a fast pointer and a slow pointer, and also in addition to that we will use the previous pointer. At every stage, previous pointer will get whatever the slow pointer was in the previous step, and the slow pointer will just go to the next step. So here one additional case we have is that once we have found the middle element, what we have to do is we will delete that particular element. How do we delete that? We will check it, and previous dot next will just be equal to previous dot next dot next. So I prefer this solution, that is using a previous element instead of just confusing with current dot next. There is one more way to delete this. I will show you, but I do prefer this because this is very easy to understand. Okay, so this is how you delete the element. If you have any doubts, please put it in the comments. So I will just run the code. Okay, so this is one solution that we have. Then let's get into the next concept. that we have. This is very important. This is where the things get trickier, and this is where from easy to medium next we will be going to somewhat harder level of problem. So here I will be discussing about how do you reverse a linked list. Okay, so let's start with this particular uh, linked list 58632. So for to make things easier for explanation, let me remove these two particular nodes. Okay, so we have 5863. What is the output that is expected? The output that is expected is 3685. That is 3 should come in the beginning, then 6, then 8, then 5. So how do we do this? Okay, so how do we do this? Let me explain this. How do we do this? Let's have this. What do we do? From the second element, we will remove that element and we will be placing at the beginning. So again, we will be removing this element and we will be placing at the beginning. Similarly, whichever was next, we will be removing and we will be placing. So here, if we look, this is exactly the reverse. So what is the idea here? We will be removing a node and we will be placing it at the head position. So the first step is to remove the node. The next step is to point the head to this particular removed node. So we start this removing from the second node. We don't start from the head, we start from the second. So what happens here? Let me just show you. So the guy is here. So we will be removing the next particular node. This is one more way of removing the node. How do we do that? Let me show you that as well. So instead of having a previous pointer, what do we do is we just change current or iterator dot next will just be equal to iterator dot next dot next. So this particular node gets deleted. So there is no need of using a previous here, but it will cause a little confusion, but it is necessary in this problem. So what do? We just remove this particular node. This will be our removed node, and then once you have removed this node, where does this point to? This will be pointing to 6, right? So 5, 6 and 3 will be there. Then what do you do the next step? The next step you need to do is you will point this to whichever the next element is, whichever the head element is. So the head element will still be 5, but we will change 8's pointer, the removed element's pointer, to the head element. So this and this head are both now pointing to 5, and we will change the head pointer from 5 to 8. Okay, so now this is the new linked list. We have 8, 5, 6, 3. Similarly, what we will do, we will again remove 6 and we will place it here. So 5 and 3 are now connected, so everyone will come down a step and 6 will go at the top, and the head node will be pointing to 6. Then comes 8, then comes 5, then comes 3. Similarly, for the last node we will be doing, and it will be the new head, then comes 6, then comes 8, then comes 5. So this is how we reverse the linked list. Let me show you by writing the code. So here we have a problem where we have to reverse the linked list. So what have I done here? So if you see what I have done here, this is one special condition where the head is equal to null. We will just return the null value or the head value. If it is not, the current element or iterator is initiated to the head element, and the next what we will do is we will be deleting the next element. So the removed element is the next element, and the iterator value will get changed to next dot next. That is, we have removed one value and this is the removed value. Okay, what do we do next? The removed value will point to the head node, that is 5 in this particular case. 5 in this particular case initially. Okay, so similarly, if you look, then the head will point to the removed node. So this process happens for all the five elements. So at the end, the complete array is reversed. Okay, let us run this and submit this. So what is the basic idea? So we remove a node from the second node and we place it at the beginning. We remove a node that is pointing and we will place it at the beginning. So this is the procedure, and if you look at it, the nodes or the linked list is reversed. So this is very important concept to understand. If you are able to understand this, now let us get into one more level of this problem. That is, you don't want to remove all, you don't want to reverse all the elements of this linked list. Instead, you want to do from a particular point. Say you just want to do just reverse just three elements, these three elements. You don't want to reverse all this, but you are given in this problem you have to reverse only these three elements. So what will be the output? The output will be 5, 8, 2, 3, 6 and 1. Let me just take you through the LeetCode problem description here. So if you look here, we will just be reversing these three. So how do we do that? I mean, if you observe here very carefully, so how do we do that? Let's introduce one concept called as the dummy head. What do we do here? So we are asked to do the reversing of the linked list from the point 6. So what do? We will create a dummy head and we will place the dummy head here, and the dummy head will actually point to this node, that is 6 node. So if you look here, now the dummy node will act as the head, dummy head will act as the head, and the reversing, instead of doing till the end of the array, what you can do is you can just do it until the given elements. So in this particular case, you are given from 3 to 5, so you just have to do 2 iterations. So you will be just be removing 3 and placing at the beginning, and again you will be removing 2 and placing at the beginning. So nothing changes. We have introduced one new concept that is called as the dummy head concept. So if you do this, just forget about these nodes. Forget even these two nodes exist. So you just reverse, and for you will also forget that there is this node. You will be just reversing in the same way, but we have done is we have introduced one new concept called as the dummy head. So let me just go to the problem and I will explain you. So what are we trying to do here? So we are trying to bring the current pointer till the previous node, till this particular node. We are trying to bring the current pointer to this particular node, and what we are doing is we will create a dummy head. So the dummy head will be the current pointer, and the current pointer will move to the next one. Okay, so all the remaining process remains the same. Instead of using a while loop, why? Because we were doing for the entire linked list, but here we are, since doing for a range, we will just be doing the required number of steps. Okay, so what we are doing, again the same procedure. We are removing a node here, and we are assigning the next value. But one more special condition that we have is, if the dummy head is equal to the actual head, what we will be doing, we will be changing the heads value. We will not be changing the dummy heads value. Instead, we will be changing the original heads value. This is one special condition, that is, when this value, the left's value, is equal to 1, we have to remember that is actually equal to the head, right? We have to do it from the first. In that case, instead of changing the dummy value, we will straight away change the head value. So I hope you have understood the solution. The main idea is here is the dummy head. Instead of having and changing from the main head, we will change it from the dummy head. So here we go. Let me submit the problem. Yeah, looks good to me. Okay, So next we will be solving one of the lead code's hard problem, that is you want to reverse the nodes in k groups. Let me explain this. So here you are given a linked list of length 5, so you have to reverse them in groups of 2. So if you see here, 2 and 1 are reversed, 4 and 3 are reversed. If you don't have that particular space, you won't be reversing that. Okay, similarly here also we are given a group of 3, 3 to 1 will be reversed, 4 and 5 will remain the same. Why? Because we don't have 3 values here, right? So how do we do this? So let me take you through the explanation through this diagram. So here we are given the linked list. So here we have 7 elements and we will be reversing in groups of 3. Okay, so what we will do first, the first thing that we need to do is check if we have 3 elements from the head node. So do we have 3 elements? Yes, we do have 3 elements. So if we have 3 elements, it is just like reversing the linked list from the beginning. It will be same, but you will do this operation only 2 times. You will not be doing it 3 times, but you will be doing the operation only 2 times, because you don't want to do all the elements. You just have to do the elements in groups, so you will be exchanging the elements in groups of 2. So these 5, 8, 6 will actually get changed to 6, 8 and 5. So 6 will come in the beginning, then comes 5, then comes 6. So 6, 5 and 8. So this particular has been reversed. So now the dummy head, where do you place the dummy head? Wherever the current element was will be the dummy head. So this will act as our dummy head now, and it will be pointing to 3. So here we have our dummy head and it will be pointing to 3. So this will just act as our new dummy head, and we will repeat the procedure again. We'll just check if there are 3 nodes available. If there are 3 nodes available, we will reverse all these 3 nodes in the same procedure. And next, where will our dummy head be? Our dummy head will point to 7. So if we look at 7, we don't have 3 nodes. So we will remember the main head node and not the dummy node. So we have reversed in groups. So let me take you through the solution. What we have done is we have initiated the current node to head node, and the dummy head at initially will be equal to null. So this remains the same. So what we are doing here is we are checking if there are required number of elements. So here you are given a value of k or b in this particular example. So we are just initiating n and m is equal to b, and if we are checking here if there are n elements. So if there are n elements, if there are no n elements, we will just return the answer. However, if there are n elements, what do? We will do the same operation, that is we will remove the node, and we if the dummy head is equal to null, we are at the main head, so we will be changing the main head's value. However, if the dummy head is not equal to null, we will change the dummy head's value. Okay, so the dummy head will at every iteration change to the current head. After that, you will just change the current head pointing to the next node, and we will finally return the head value. Okay, so in this session, that's it from my side. In the upcoming session, what we'll be discussing about is we will discussing about merging of 2 sorted arrays, and also merge sort of a linked list, and also how do you merge k sorted elements. This is a very hard level problem. Then we will be discussing about cycle in a linked list, length of the cycle, and starting point. So in this video, we have discussed about 2 concepts. One is search concept and delete concept. With just these 2 concepts, we were able to solve hard level lead code problem, and I want you to try 2 more lead code problems that are actually easy level. One of them is the palindrome linked list. You have to check whether a linked list is palindrome or not. So here you have to use two concepts. If you do not get how to solve this problem, just comment me, I will be answering this. The second one is to remove duplicates from the sorted list. So you can try these two problems, and in the next session I will be discussing these parts. Thank you for watching the video. Please do like and subscribe. It will motivate. Thank you. Have a nice day.